So, my name is Meghana Nasre. I am a faculty in the computer science department, and I am always excited to teach this course. I have taught this course twice, and I am very happy that this time I am getting a batch of students which is diverse, which has students from all different departments. So I'll get to experience a very nice thing. So I hope that all of us enjoy the course together and learn something from each other. So without further ado, I'm going to start the class. We are a few logistics first. We are going to have 4 lectures per week. And the lecture schedule is as follows. We have lectures on Monday, Tuesday, Thursday, and Friday. The Monday and the Tuesday lectures are slightly longer, and the Thursday and the Friday lectures are going to be 50 minutes each. Together, we will make up for 250 minutes of lecture hours in a week. And if there are some small changes due to some holidays, we'll make it up as we go along. We are also having 2 lab slots, and while the lab slots are start at 2 on Thursdays and Fridays, we'll be starting at 2:30 on Thursdays and Fridays, and we will be ending at 4:30. So this is the lecture and the lab schedule for our section. For this week alone, because we lost a few classes, we are going to have a slightly different schedule. That is, this is the first class, which is 10 to 10:50. We are going to also meet today in the afternoon, which will not be a lab, but which will be a regular theory lecture. And this lecture will be from 3:30 to 4:30. Please note the time. It will be an afternoon class. The same link will be used, and I'll be posting it on the Google group again. Tomorrow we have a regular lecture at 9 o'clock, and then we will have the first lab of this class at on Friday, 2:30 p.m. So we will be giving you clear instructions on what we are going to do in the lab and so on. But this is the plan for this week alone. So today in the afternoon, we are meeting again at 3:30 p.m. Okay, so with this, these are the small logistic things that I wanted to tell you. We are going to get started with the actual material. So I want, yes.
Ma'am, is the lecture link the same for all the days?
Sorry, I can't hear you.
Is the lecture link same for all the days?
The lecture link will be the same, for all the days. And I'll be announcing that. Yes, it will be the same.
And for labs?
So labs, we will announce how we are going to conduct the labs. I will give clear instructions by the end of tomorrow's class.
Okay, ma'am. Thank you.
Yeah. So, yeah, it is very nice that students are asking questions. So if it is a student who is asking question, I'll request you to introduce yourself by saying that I am so and so from this department. That will be very helpful for me. Okay. So, anything else regarding the lecture or the lab schedule? Okay. All the announcements for this course will be posted on the Google group. So please make sure that you are registered on the Google group. In case you are not, we will take it offline. I'll talk about the logistics part towards the end of this class. Okay. So having said this, we are going to get started with the actual material. But before I get started, I want one person who is going to be a volunteer. Actually, I want 2 people to be volunteers amongst the students, and one of them, if possible, should have should be able to share the screen. So can I get 2 volunteers? Like, you don't have to do anything very fancy, so don't worry. It's something very, very simple. You are not going to be asked to write code or anything. Can I get 2 volunteers from the participants?
Yes, ma'am. My name is Vidushi.
Okay, Vidushi is one person who has volunteered. There is another who has written in the chat. I couldn't catch the name. So Vidushi is one.
Arjun, I can volunteer.
sorry, Arjun, is that the one?
Yeah. Yes, ma'am.
Okay, so we have Arjun and Vidushi as the two volunteers. So what we are going to do is a small exercise, and for that, the person who is going to be the one. So I'll just pick any one of you. So Vidushi, will you be able to share your screen for us? I'm going to stop sharing my screen, and I will ask you to share the screen. Right?
Okay.
So, Kaushal, you have to tell us whether you can see the change in the screen sharing.
Yes.
Are you familiar with scenes? Yeah, okay. Great. So, Vidushi, I would request you have some kind of a notepad or some editor on your machine. Could you open that? Great. So yeah, excellent. So now this is what we will want you to okay. So now there is a small part where you will feel like there is a suspense, but don't worry, you are not going to miss anything. So we are going to ask you to leave the meeting for a few minutes and then come back. When you come back, you are going to join our meeting. You are going to share this screen and you are also going to follow the instructions of what Arjun tells you. And he's going to give you a clear set of instructions and you are going to follow them meticulously. Is that clear to you, Vidushi?
Yes, ma'am.
Okay, so don't worry, you are not going to lose any part of the meeting and you'll anyway see the recorded part, right? Okay, so may I request you to leave the meeting for 2 minutes and join back after 2 minutes.
How am I supposed to send the instructions?
I will tell you, let her leave the meeting.
Okay, I'm leaving.
Okay, so Vidushi, you can say that I'm leaving the meeting. Okay. I think she has left the meeting. I'm going to go back and share my screen. Okay, so can Arjun or Kaushal say that they can see the screen again?
Yeah, I can see your screen now.
Okay, great. So now here is the exercise. So all of you can see while these two are the volunteers, but I see that all of you are seeing the patterns on the screen. These are very simple patterns. What is our goal? Our goal is to request our ask our volunteer to draw these patterns in her text pad as it is, except the colors and all, because we don't have colored pens right now and we don't want to get into that. But we want our volunteer to draw these patterns on the notepad that she has opened, right? So I request you to think about how will you communicate. Of course, Arjun is going to communicate these things, but how will each one of you communicate it to a friend who has not seen these patterns? This is our goal. Right? So, Arjun, if you want, you can also take a screenshot or something, but of course, don't send it to Vidushi, even if you know her. And the goal is as follows. We know how to draw these patterns by seeing them on paper, but how would we describe this to a friend on phone or somebody who has not seen this? So just to simulate this exercise, I have asked her to leave, and when she joins back, Arjun is going to give a clear set of instructions. So Arjun, can you tell us how would you describe it to her? What
For the
are the
first one,
thoughts that you?
I would say 8 stars, an enter, then one more enter, then 8 more stars, 2 more returns, then 8 more stars, 2 more returns, then 8 more stars.
Okay, so one rule that we will follow is that while Vidushi can understand high level commands, somebody may or may not be able to understand high level commands. For example, you could have described pattern 2 as some kind of a staircase or pattern 3 as a hollow box or something, but we are not going to give instructions of this form. So we are going to give instructions in, of course, what you said, stars and enter and so on, but we will use only these 3 commands. Draw a star, go to a new line, and repeat a set of commands k times, right? These are only the 3 commands that you can use to communicate with Vidushi.
Okay.
Is that clear? Okay, so now I am going to stop sharing my screen. Okay, so while we are, okay, so I'm just going to stop sharing my screen. I'm going to hope that Vidushi joins. Till then, without describing the patterns or without talking about the patterns, because we don't want Vidushi to know about it, does anybody have any questions or anything what we are doing or any kind of question?
Excuse me, ma'am.
Yes, please
Ma'am,
introduce yourself.
okay, I'm Kanikeshwar from mechanical, ma'am. Mechanical branch.
Yes. Okay.
Actually, I have a problem. I'm not able to see the screen which you shared, ma'am. I'm just able to see viewing your application, but the screen is black. Actually, I'm not able to see anything.
Okay. So I will just check with others. So if are others able to see it?
Yes, ma'am, I could see.
Couple
I was
of,
able to see it.
okay, Arjun says.
Supposed to come
So,
back now.
hello.
Yes, ma'am. This is Vidushi. I was sure when.
Yeah, you have joined the meeting, right? Okay, great. Yeah, just hold
Yes.
on. We are yeah. So we are looking at some other technical issues. Somebody is unable to see the screen and so on. So
Okay.
yeah. So
Yes, ma'am.
can people? Yeah. Thank you for leaving and joining again. And we promise you that you have not lost anything. Okay. So yeah, so I think some people are unable to see it. If it is a small number, I don't know, maybe you have to leave and join the meeting again. If majority are able to see, mostly the problem is not at my end, hopefully.
Okay.
So I request people who are unable to see, maybe leave and join the meeting again and see if it works. Okay, so we'll continue. So Vidushi, we ask you to share your screen the way you had done and open the text editor.
Yes, ma'am. 1 second.
Okay, great. Yeah, so are people able to see Vidushi's text editor? People who are unable to see mine, I mean the sharing that I was doing. Okay,
No,
if I
ma'am.
don't get any response. Okay. Yes, so was it Nikhil from ME? Nikhil was saying, okay, you can see. Oh, Karthik is saying, yeah. So if you can't see, can you please write that you can't see? Because these are the people whom we need to address it. Okay. Okay, so for somebody from ME, Pannikeshwaram, I think it is not.
Now it's fine, ma'am. Now it's fine.
Okay, then we'll move on. There will be some issues initially, but we'll have to work around it. Okay, so yeah, Vidushi, can you, so now Arjun, you are going to give her clear instructions to draw pattern 1 first.
Okay.
And the way we
Vidushi,
have, yes.
draw an asterisk.
Drawer.
A
Yes,
star.
that is
A
good.
star.
Yeah, fine. So Vidushi, one more thing is if you can zoom a little bit so that everybody sees it, or draw
Yes.
it a little bit in the center.
Yes, ma'am. Is that better?
Great. This is excellent. Yeah.
Draw a star and do that 7 more times. Go to a new line. Draw a star again.
I am unable to see the star drawn on the new line by Vidushi.
Oh, ma'am, I can't hear. What was the next instruction?
go to a new
Yeah.
line.
Yeah. That.
Repeat it 7 times again. Do the same process 2 more times.
Excellent, excellent. So now, Vidushi, you have drawn a pattern that Arjun and the whole class had seen, and the point was to communicate to somebody who has not seen the pattern. So Arjun, would you be able to communicate, or does anybody else want to communicate the third pattern to Vidushi? All the class has seen it, so is there some other volunteer? If not, we'll pick Arjun again.
Yeah, ma'am. I'll try.
Sure. So please introduce yourself.
Good morning, everyone. Siddharth Sharma from Naval Architecture and Ocean Engineering.
Great. So Vidushi, Siddharth is going to give you further instructions to draw some pattern. You can leave this pattern and just move a little few spaces down. Yeah. Okay. Yes, Siddharth, can you please give her instructions?
Yes, ma'am. Sure.
Yeah.
Vidushi, start with 2 asterisks in the first line. And then keep on increasing the number of asterisks per line, like 3 in second, 4 in third, just like that.
Whenever you want me to stop.
Yeah, even I don't remember how many lines were there, so I guess you can stop after 5.
Okay. Okay. So we'll stop here. Okay. So if somebody in the class remembers, was this the pattern? Second pattern?
No, ma'am, there were powers of 2, I think. Multiples of 2, not powers.
2, 6, and 8.
No, ma'am.
Okay, so yeah, okay. So this pattern is slightly different, Siddharth, from what we had shown. And it was in fact 2, 4, 6, and 8. This was the pattern. So, okay, I'll come back to our takeaways from this exercise. Somebody else, can you please describe Vidushi? No. So Vidushi, don't change what you have drawn. You have drawn exactly what Siddharth has told you. Yeah. Okay. So now, can somebody else volunteer to tell Vidushi the patterns that we have, that the third pattern that we have seen?
Ma'am, I will volunteer.
Okay. Please introduce yourself.
Hello, everyone. I am Pramat Shastri from Aerospace. Okay.
Pramat, you have to speak a little louder.
Is it better?
Yes, it is good.
Okay. So Vidushi, in the first line, please draw 8 asterisks. Go to the next line. Yes. 1 asterisk. Draw 1 asterisk only. Give 6 spaces. And 1 more asterisk.
Sorry. Yep.
Repeat this second line for 3 more times.
Okay.
And in last, complete the pattern with 8 more asterisks.
Okay, excellent. Okay, so I will, I thank all the participants who have volunteered and everybody who was attentively paying attention and doing all this exercise carefully. I hope we all saw what is happening. I will now request Vidushi to stop sharing. Thanks a lot, Vidushi, and thank you, everybody. I'll go back to sharing the screen. Yes, okay. Okay, so Vidushi is the only one who has possibly not seen what was happening. So these were the patterns that we had shown everybody, and these were the patterns that you were supposed to draw on paper. So I think the first pattern we drew exactly the same. The second had some small errors. The third one again, can the class tell me whether, so Vidushi, did you draw this pattern? Exactly.
I think there was an extra thing.
Correct.
He said
Okay.
repeat
So there was
twice
one
after the first. Right. Yeah.
Right. Okay. Okay. So what I want to bring out, okay, so and the rule that we had decided was that we will use only these commands: draw a star, go to a new line, repeat a set of commands k times. So one thing is that, okay, can somebody say whether we really used only these commands when we were drawing these patterns, or did we use some additional commands?
In the third pattern, we use an additional command of space.
Great. So we couldn't do with these commands, but we used an additional command of of saying that draw a star with a space. So I'm just saying what we had done earlier. So suppose we had to draw the pattern on the left hand side, we would have told our friend, or in this case Vidushi, repeat 8 times, draw a star. So this is what we know as indentation. That is, whenever I'm saying that draw a star is inside this repeat, you are going to repeat this, whatever is inside, 8 number of times, or whatever number of times it is written. Go to a new line and then repeat 8 times, draw a star. And we saw even in these simple patterns, while the patterns were shown for only a small time, but these were very simple patterns. So what we learn is that we need to precisely record these patterns in our mind or on the paper, or describe it to them. Else, we will make some mistakes. For example, the second pattern that was drawn was slightly different from what we have drawn it here. It did resemble the staircase, but it was a different pattern. So if you do an exact match, it doesn't turn out to be the pattern that I had in mind. Similarly, the hollow box was slightly different from what I had shown you here. So what we realize is that if we want to communicate to somebody, we need to first understand it ourselves clearly, and then we need to precisely communicate it with a set of commands that the other person understands. Because Vidushi understands the same language that we are talking, that is draw a star or draw an asterisk means the same for both of you, it is clear. Similarly, the commands that I had given were not enough for you. So you yourself defined a new command which says move right without drawing a star. Again, you may have used a different language, but you said that give spaces, but nevertheless, you had to define a new command which was move right without drawing a star. So what we have achieved here is that we have described simple patterns using a set of commands. These commands have to be precisely understood by the person who is giving the command and the person who is executing them. And whenever required, we are going to introduce new commands. And also, because if they are very different or new commands that the other person does not know of its meaning, then you are also going to inform your friend of the meaning of that command. So this is what is a small exercise that we have done. Any questions, any comments on this exercise? Okay. So what we did here is, all of us in the class are actually going to the people who are going to give commands. The person or the thing to which we are going to give the command here, Vidushi kindly agreed to be the one who is going to take the commands from us. The person or the thing that is going to take commands from us is the computer, and that is your friend. You have to give commands to the computer to do what you want, exactly the way you want. And for that, you need to understand the language of the computer, and you have to be able to program. So have we actually written a program? So a program, we have never even defined what is a program. A program is a precise description of steps that we want to perform on data. At the moment, we are avoiding the fancy part of it, but we don't have too much data at the moment to process. But there is implicit data which we'll come to. But we did write a program, but we did not. But the way we wrote the program, or the way we have defined the commands, this is not the language of the computer. So the computer does not understand draw an asterisk, draw go to the right and so on, but it does understand some other language. And to learn the language of the computer is the goal of this course. That is, we are going to learn a language with which you can communicate effectively to the computer and get it do the tasks that you want to do. And in fact, all of you have seen this to some extent, varying degrees of exposure you have to this part, because you have already done a programming course in your 12th standard. So you understand this. I want to emphasize that this is what we are going to achieve throughout the throughout our course. Any questions, any comments on here till here? Okay. Okay, great. So what we are going to now do is we at a very high level, we have simulated a computer. Like actually Vidushi became a computer or somebody who is willing to take the commands and execute them. We are now going to work at a slightly higher level and work with what we will call as a turtle trained computer. And I'll say what a turtle trained computer is. It is not a thing that is of my imagination. In fact, I will tell you that I have my computer is turtle trained, and you can turtle train your computer as well and play with it. And it's not at all difficult. So this is what we are going to do. I just want to take some sense of anybody who has worked with a turtle trained computer earlier. You may not call it turtle trained computer, but have you worked with a turtle in some programming language or something?
Logo.
Excellent. So some of you have looked at it. Anybody? So can you introduce yourself? Whoever said logo.
Arjun again, man.
Sorry.
Arjun
again. Okay. Arjun, you are the same one who gave
the same.
Yes.
Same one.
Okay. So have you worked with turtle earlier? Or you know about it?
I worked with Logo somewhere around 4th or 5th
You have
standard.
worked with Logo. Okay, so you will possibly have some familiarity with it, but anybody who has seen this may have some familiarity, but nevertheless, everybody can appreciate what this turtle trained computer is going to do, and it doesn't require any exposure. Just like giving the set of commands to your friend did not require any exposure to programming, but it was a set of precise instructions. Okay, so for the moment, imagine that we have taught a computer to display a turtle. A turtle is some kind of an arrow just for the moment, and the turtle moves according to the commands that we give to the turtle. So just like what we had defined our commands as draw an asterisk, move to the right, go to the new line, repeat. Similarly, the turtle trained computer knows the following. It knows forward n. So n is the number of pixels. All of us understand that a computer screen has several pixels. So when we say n, the unit is in pixels, and it will move forward in the same direction that it is headed to. So the turtle has a head and it just moves in the same direction. So this is the meaning of this command forward. We should also understand what the turtle commands mean to the computer so that we can give commands accordingly. Similarly, left D, where D is in degrees, tells the turtle to turn left. Similarly, there is a right, but at the moment left is good enough for us. And then there is wait, for which the unit is in seconds. It tells the turtle not to do anything, just hold on, wait, right? So these are the only 3 commands that we have taught our turtle, or the turtle knows for the moment. And using this, we are going to write a small set of commands, and what I will display to you is a set of commands. You have to stare at them and then write in the chat what do you think is going to be the drawing, or what will be the end result after the turtle has done these things, right? So are there questions on this part about the meaning of the commands?
Ma'am, we have the degrees can take like continuous values, right?
Yes, but at the moment we are going to just give it integers. Yeah, let's simplify things for the moment. Yes, it can take values which are real numbers. You mean real numbers, right?
Yes, ma'am.
Yes, but at the moment we'll just work with integers. We'll see when it is required. Yes. Okay. Any other question on the commands or the interpretation of the commands? Okay. So I'm going to now show you the small program. So do not worry about the lines which are includes, because this is a program which will actually run in my machine. So I'm writing the whole program as it is. You can, for the moment, ignore this include simple CPP main program, these braces, and the turtle sim. But just read these commands forward 100 after this till this wait 5 and take about 10 seconds and okay, yeah, so I see the answers. Yeah, please everybody stare at it and then give answers. Okay. Okay, so I see a lot of people answering that it is a square. There are some people who says that turtle comes back to the same place, which is also correct, but it comes back to the same place after drawing a square of side 100, which is perfect, which is what it does. We are going to do this on my computer. For that, I am going to share my screen, and I'm also going to tell that how can you train your computer to be a turtle trained computer. Is it required? No, but it is fun and you can do it for yourself and you can play around with it, right? So before I show you this, is there any question on this thing? It ends and the output screen will be closed. Yes, all those things are correct. Yeah, are there any questions or things apart from the fact that it draws a square? Okay, so I'm going to, so this is not a mock program or something which is of my fancy. I'm going to show that this will work. Okay, so there is a question, what will happen? Okay, so what will happen when you say wait 5? I will show you exactly what happens. Okay, so now this is something which is a turtle trained computer. I will just show you what, okay, so stop showing. So Kaushal, are you there in the meeting? Kaushal is our TA. I just want to check, is he there in the meeting?
Yes, ma'am. I'm there in the meeting.
Yes, Kaushal. So I would want you to confirm that you see what I'm sharing now, because yeah, so it should be showing my whole screen, right? Is that correct? And yeah. So can you see that I have an IDE where it says square.cpp and there is something written? Is that what is the view that you're? Okay, great. So everybody can see that I have written exactly the same program. If there is any difference, please tell me. So there is some small difference in the indentation, but I'll just bring it there. Okay. Yeah, so this is exactly the program that I have shown you, and I am going to run this program. As I said, for the moment we will ignore this include simple CPP main program turtle sim. I'll describe to you what they do, and but at the moment ignore it. But what is more interesting is how this turtle operates, and I'm going to compile this program. And yeah, Kaushal, I would like you to tell me whether you can see the execution on the screen.
Yes.
Yeah. So does everybody see that the square is drawn and it has come back and it has also stopped showing us? So this is what it did. What I'm going to do is show it to you slowly so that you can see what is happening very slowly. So we'll wait for 5 seconds after every time what we do. So I'm modifying the program to ask it to wait after it has drawn a segment of 100 pixels. And this 5 is just telling us to wait for 5 seconds. Okay. So I'm again going to compile and run. So now you see that after it has drawn 100 pixels, it is waiting. Then it turned, it again drew 100 and it's waiting. It's again drawing 100, it's turned and it is waiting. And then it is completing the square. It will wait for 5 seconds and then it will close the turtle simulator. Okay, so this is what is happening on a real computer. It is not very difficult to train your computer to have this turtle. I will give you the link and you will be able to do that. But before that, I'm just going to look at the chat and see what are the questions that people have. Okay, what will happen if the cursor starts from the top left corner of the screen? Would a left turn be possible then? Very good question. Try it out. Okay, so Sujit has written this question privately. Sujit, please try it out. We can also try it out in the labs and so on. But at the moment, it's a slightly more advanced question. I'll wait for answering it to you, right? Okay. Any other question about what we did? Okay. The initial direction is default. Yes, the initial direction is going to be default. It is pointing to the right side or the east side, whatever you want to say, right? Okay. So what we have done are, can we adjust it? Yeah, possibly we can adjust it. I have not played around to it, try and adjust it, but possibly it is possible to adjust it. We have to play around a little bit. Okay. Yeah. So, what are our takeaways? We have seen one computer which has been trained with a turtle. We have drawn a square using the turtle. How will you make the turtle draw a triangle? It's not difficult. Again, don't give answers right now. We are going to come back to all of this towards in the second part of the class today that we have. How about a hexagon? How about a decagon? And then why stop at polygons with finite number of sides? What about a picture that looks like a circle? So how will you draw that? And can I train my laptop or computer to understand turtle? Very much, yes. This thing has a link which I hope it is showing up. It is this is in fact, I should tell you, all of you have learned programming. So many of you may have also done C++ programming. It is just a wrapper on C++, which is called simple CPP. While I use the word just, is not to say that the effort is less, but in fact it is a very useful tool. But what I'm saying is it is nothing very different from what you know. It is C++ with a wrapper with the turtle and some additional commands. So you can use this link to download it. On Windows it is very easy. On Linux machines also it is fairly easy. I have tried that. On Mac I have not tried it, but I'm sure it should work. So this you will get the link from the slides. Do you need a turtle? Yeah, I'll come to the question. Do you need the turtle trained computer in the course? No, in fact, this is for demo purposes, and we will come to it when we require it. But we will not be using it extensively throughout the course. It is to tell what do we mean by communicating to the computer. What do you mean by communicating to the device precisely? How do we do the same thing in C? It's not it's not impossible. You can do it. It will require a lot of work to have a turtle simulator there. This has been done already for you in C++. We are not going to expect you to do these things in C, but the purpose of this is how to communicate to a computer precisely without getting into the low level syntax. That was the purpose of today's class. So, so we are not going to do it in C at the moment. So we are going to use a C-trained computer or a platform that we will introduce you to throughout the course. But at some points, if required, we'll go back to the turtle and we will ask the turtle to do some things which you will locally do it on your machines. So to summarize, what have we done? We have, in the first part of the class, we asked our trained friend. In fact, we did not even have to give any training to our friend Vidushi because we all understand the same language. But when we asked her to draw an asterisk, she did draw it. So she is in fact a trained friend. And these were English instructions and therefore the training was almost not there or minimal. Then our turtle trained computer drew a polygon, in fact a square, and these were also short instructions. It has been abstracted out to let us give it nice instructions and do something on the screen. So the takeaway from this is that if you want to tell the computer something, you should know, the computer should know the meaning of the commands and we should give them with precision. If we give them with precision, the computer is not going to change anything that you tell it to do. It will exactly follow it meticulously and do these steps. And computers are already trained in many languages like C, C++, Java, Python. And how does one train a computer? That is something that is slightly for later. But this programming language that we call is a means of communication with the computer. And if you want the computer to behave or do things exactly the way you want it to, you must learn this language of communication precisely. And this is the goal of this course. So in this course, we will be talking about the C programming language, which is one of the most popular programming languages. It has been developed by Dennis Ritchie, and it is used extensively to write large softwares at different places. Once you learn a language, you can pick up any other language. So the choice of language should not bother you too much. It's perfectly fine to learn this language and then move on to some other language. So was the turtle program written in C? No. Yeah. So the turtle program was not written in C. It was written in something which is a wrapper on C++, which is called as simple CPP. So what will we do in this course? We will be learning C, and C and C++ are I mean, yes, there is a paradigm shift in C++, but we are not going to learn C++ in this course. We are going to learn C. We will go to turtle at some points to illustrate certain concepts, which we will remember that, okay, we are not writing this program in C, but at the same time, whatever we want to illustrate using that turtle trained computer, we will do that. So the course is C programming course, but at some points when required, we can go back to turtle and ask the turtle to do some things. Okay, so what are the goals of this course? We want the computer to solve problems for us. The language of communication to the computer is the C programming language. What are the kind of programs that you will write using in the middle and towards the course? Maybe you will compute statistics on large files. You will write a 2-user tic-tac-toe program. You will, of course, learn very important and ever-pervasive sorting algorithms. Then sorting is something which we do every time, and it cannot be overemphasized, the importance of sorting data and the algorithms that we know, but we need to teach or we need to communicate it to the computer. That is what we will learn. And then we'll also learn simulating simple Unix commands. These are sample programs, but to reach to this, we will have to start slow and we will have to learn basic things like the syntax of the language and so on, which are the language constructs. But throughout the course, our goal will be to have fun, enjoy, and make the computer do tasks that we want it to do. So I would like to present an analogy with the languages that we learn when we learn spoken languages. When we learn a new spoken language, let's say you are from Gujarat, you want to learn let's say Bengali, you are going to learn the words, small words of the language which occur frequently. Then you are going to learn the grammar. Sorry, there is a typo there. Then you are going to learn, you are going to read good literature. Once you understand the language, you are going to read good literature. And later on, if at all, you will possibly write in that language. In a similar way, we are going to learn commands of the programming language. We are going to then learn the syntax of the language. How do you take constructs, put them together? Then analogous to reading good literature is know what problems can be solved using this language. Every programming language will allow you to solve all problems, but it will be easier or difficult in some programming languages. And then we are going to design good solutions to problems of our interest, right? So this our interest is going to be decided more or less by what we think is interesting to the general class, but hopefully it will cater to interests of everybody in the, some problems will catch interests of everybody in the class, right? Okay. So I will end this class with a well-known quote, and you must have read this earlier. I hear and I forget, I see and I remember, and I do and I understand. So I encourage all of you to experiment, do things, try out things. What will happen if I do this? What will happen if I change this code? If I change if I change this wait to 10 seconds, what if I do this forward to 200? What if I do this left to right? Try it out and see it for yourself. You of course need some basic hand holding. We will be very happy to do that. But please make sure that you do rather than you simply hear or see. So this will be what we will be trying to do throughout the course. And okay, so finally, what are the books and something that is of interest, that is the evaluation for this course. The books, there are several books. This Detail How to Program in C is a very popular book, which you can use as a reference material. There is also this book by Professor Abhiram Ranade, whose team has developed this simple CPP, which we illustrated. So you can use that book, which is titled as Introduction to Programming Using C++. That is also available. There are, of course, Kernighan and Ritchie, which is the classic C programming language book. So coming to evaluation for this course, our course, we will have 3 exams. Each exam will be 20 marks each, which will account for 60 marks for the course. We will have lab assignments which are worth 40 marks, and we'll have 8 graded lab assignments. Tomorrow's lab assignment will be ungraded, but it is very important that all of you attend. If you do not attend, you will have to justify, otherwise there will be a penalty. And the tentative exam dates are May 3rd, May 24th, and June 14th. These are all Mondays. These are roughly spaced at 3 weeks. We have a 9-week course. So these are the tentative exam dates. I say tentative because we need class committee approval for this, but please mark your dates mark your calendars for these dates. Okay, so coming to the final part, some very important logistics about the course. You are assigned a TA. Your TA has already contacted you. Please know your TA well. If you have not been assigned a TA or you have not been in touch with the TA, please write to me. You should be added to the Google class group. If you haven't been added or if you did not receive the first class link, you should write to me or your TA. All announcements, as I mentioned, will be made on the Google class, Google group, not on Moodle. So please do not get confused if there are messages sent on the Moodle, but all the announcements will be done on the Google Classroom. And I want to acknowledge gratefully what the material that I have been using. This is prepared by the members of the CSE department. And as I said, I have taken a lot of ideas from the book by Professor Abhiram Ranade, who is also my teacher, and I have learned from him on Introduction to Programming Using C++. And the simple CPP package is in fact developed by him. And of course, if there are images in the slides, they are all taken from Google. So to conclude this, I want to remind you the first week lecture schedule is slightly different. It is going to be, today we are meeting at 3:30 again. On Friday, that is tomorrow, we have a regular 9 o'clock slot. And then in the on Friday, we'll meet at 2:30 for our lab. Yeah, so okay, so that is what that ends the class. If there are questions or comments, you can ask. Somebody has asked me to show the exam date, so I'm just flashing that slide. Okay, so I'm going to stop recording. If there are questions, please ask me. I'll be happy to answer. And